Okay. So today we're going to review for the for tomorrow's test. Basically, we're going to have focus on chapter 8 and a little bit of chapter 9. Chapter 8. So first we did integral by parts. I think we did some problems in test 1 as well, right? Integral by parts, which you basically use tabular method. Okay. So first question, integral by parts, x cubed e to x power 4 dx. Okay, then here since we have an x cubed, x power 4, we can use the u substitution. So u equals x power 4 and du equals 4x cubed dx. And we can do that, we can change that to x cubed dx as du over 4. So basically, we can do this as a u, e to the u, and du over 4. So we got eu over 4. My bad. It's the e to power u over 4 plus c. So you're going to have e to the power x power 4 and 1/4 and plus c. First one makes sense, right? Yes. Like integral parts or u substitution. Next one. Okay. So 1 over x squared ln 6x dx. Do you still remember how to do this one? U as what? U as ln 6x. Okay, so v dv as x to negative 2, and du equals 1 over 6x multiplied by 6, so it's 1 over x. And antiderivative of dv, so it's x to negative 1 over negative 1. Okay, make sense? Okay, this is u, this is dv, and then what you need to do is plus, and you have this. Okay, you got ln 6x multiplied by negative 1 over x minus, this is a minus, so minus minus will give you a plus, and what you got here, this is 1 over x again. So negative never cancel out, is 1 over x is 1 over x cubed square dx. So the answer is negative 1 over x ln 6x minus 1 over x plus c. Yes? Okay. Alright, so you can change it, you can check the back if your antiderivative is right or not. You take the derivative on this one and add the derivative on this one, see if you got the right answer. I think it's right, okay? Alright, so in the end, you can have this. Next one, number 3. X sine x dx. Okay. How to do this one? Can anyone tell me?
Tabular method.
Yeah, tabular method. U as x 1 0. dv is sine x, and antiderivative sine is negative cosine. Wait, it's cosine. My bad. Oh, it's negative cosine, right? Antiderivative sine is, you take the derivative cosine, give you a negative sign. Yeah. Okay. The antiderivative negative cosine is a negative sign. Plus minus plus. So your answer is going to be negative x cosine x minus minus is a plus sine x plus c. Does this one make sense, everyone? Okay. All right. So number 4. Okay. Number 4, use tabular method. Right. I would suggest you look at this one make sure you know how to do this one for sure, because I've explained this problem many times. E to 3x cosine 4x dx. What you need to do, you do u as cosine 4x. Okay, dv is e to 3x. And take a derivative u as 4, derivative cosine is negative 4 sine x, 4x. Antiderivative is negative e to 3x over 3. And then derivative of the 4 cosine is negative 16 cosine 4x. And then this is e to 3x over 9. What do you have? Use tabular method, plus, minus, plus. So cross multiply. Alright, so you're going to have antiderivative of e to 3x cosine 4x dx equals cosine 4x e to 3x over 3 minus is plus 9 4 sine 3x sine 4x sine 4x e to 3x and minus 16 over 9 cosine 4x e to 3x dx. So what you need to do next, you need to shift this one to the left side, if you remember, okay? And then we were going to have 25 over 9 e to 3x cosine 4x dx equals 3 cosine 4x e to 3x plus 4x e to 3x. No, my bad, 4 sine x. 4 sine 4x. Okay, so the 4 sine 4x e to 3x. Then what you need to do, you can cancel the 9. So the antiderivative e to 3x cosine 4x dx will equals 25 3 e to 3x, you can factor it out, and 3 cosine 4x plus 4 sine 4x plus c. Okay, I can have a plus c right here. Does it make sense? Okay, this part I have explained at least 3 or 4 times. Okay, I'll explain it again. If you have trouble with this one, go back and do it again yourself. Okay, make sure you know how to do this one. Okay, it's number 4. Alright, so number 5. Sine 2 theta cube square root of cosine 2 theta d theta. So, can anyone tell me how you do this one? If you don't look at your notes,
I think we can make the sine 2 theta cube to sine squared theta.
That's right. You can split in sine 2 theta square root of cosine 2 theta. What you have combined another sine 2 theta, split into this two. But I want to use the sine 2 theta d theta as a d of cosine. So what I need to do, I switch this one into 1 minus cosine. The reason I do that, because I want to do u substitution on cosine 2 theta. So what you have now, this is just a d of cosine 2 theta, and you have a negative d of cosine theta over 2. Right, derivative cosine is negative sine, and you have a 2, so divide by 2. Don't forget to divide by 2. So you can take a negative 1/2 out, and it's going to be, you can distribute that. It's square root of cosine 2 theta minus this 2 give you cosine 2 theta to power 5 over 2 and d of cosine 2 theta. So cosine 2 theta can choose as a u. So basically you have negative 1/2 of, if your u equals cosine 2 theta, you can have u to 1/2 minus u to 5 over 2 and du, right? So this is a polynomial function, negative 1/2 u to 3/2 divided by 3/2 minus u to 7/2 divided by 7/2, and then plus c, and then change the u back into cosine 2 theta. That's it. Does that make sense, everyone? Okay. Number 6. Okay, number 6, I want you to do it by yourself right now. Alright? I want you to do number 6 right now by yourself. So without looking at your notes, see if you can do that. Okay, did you got it? Alright, so can anyone tell me how you got it?
We can split the secant for squared x. That's going to be p of 10 squared x. P of 10 squared x.
That's it?
We can put the secant squared x to 1 plus 10.
No, I mean this one? Is that what I got?
Yeah, when we include.
Okay, so here you missed one thing. Divide by 2, right?
Yeah.
Okay, so a lot of students, when you do that, you can see I divide by 2 here. So here you have divided by 2y, because when you take the integer, you just put it back. Normally, you want to see if you're doing it right or not. You can do it back. Take it back, divide by 10 second. That's right. And you have the chain rule. You have another 2. Well, the previous one does not have a 2 here. So you have divided by 2 to balance it back to whatever it is before. Make sense, everyone? So divided by 2 is not a big problem. You can take it in front of that. And then you can change the second into 1 plus tangent. So d of tangent 2x. So now it's just the u stuff, right? So it's half of tangent 2x squared plus tangent 2x power 4 d of tangent 2x. Okay. So what you have is half of tangent 2x cubed over 3 plus tangent 2x over 5 and plus c. Did you all get the same thing? How many of you got exactly the same thing like this? Only 3. Did you all miss that too? Okay, very good. Okay, this question is you must how to know for sure. If I change the sign, tangent to sign, like for example, you probably have sine 2x squared cosine 2x4 like that. Okay, so but this question is a must know. You must how to know this one because the integral is trigonometry integrals. And also another one you must know is this one. For sure, because you have what? Why? Because I have this one explained several times and it's integral by parts. And it's a Tabular method. Alright, so next one. 7. Problem number 7.
For number 6, do you have any preference if we multiply the 1/2 among the 2 other values, or does it matter at all?
Oh, it doesn't matter at all. If you got this one, that'll be enough. Okay? If you want to distribute it, it'll be fine. As long as you don't make any mistake, that'll be fine. This will be enough for me. Okay?
Okay. Thank you.
All right. No problem. I think probably when you do your homework, probably they prefer you multiply it out. I'm not sure, but in the test, this will be enough. Alright, so number 7, sine negative 4x cosine 3x dx. This requires you use one of the formula. The formula, I hope you still remember the formula, is sine alpha cosine beta equals half of sine alpha plus beta plus sine alpha minus beta. Okay. Once you know the formula, you will be able to do it. So it's half of sine negative x plus sine negative 7x. So dx. Then you can separate it. It's just a simple one from here. Alright, so number 8. Negative 4x 4 pi sine x squared plus 1. Alright, so can anyone tell me how would you do this one? Power reduced formula. You remember it? Okay. So the 4 here is not big. The 1 is not a big problem. So power reduced formula negative 4 pi. My bad. Is 4 pi. It's not x here. Negative 4 pi positive 4 pi. Power reduced formula. What is sine x squared?
1 minus
Minus cosine 2x, right? Plus 1 dx. So 1/2 and a 1, you can combine them. Negative 4 pi, 4 pi. 1/2 plus 1 is 3/2 plus cosine, negative cosine 2x. Oh no, my bad. Minus cosine 2x over 2 dx. So what you have is 3/2 of x minus antiderivative cosine is sine over 2x over 4. Plug 4 pi, negative 4 pi, 4 pi, plug in 0. Plug this one into here is 4 divided by that is 2. 2 pi, 6 pi, we got 12 pi. Okay. Any question? Next one? No question. Alright, so next one. X squared over square root of 64 minus x squared dx. I want to do this one by yourself right now. So x equals 8 sine theta. When you do this kind of problems, you need, if you need help, then which means you need to prepare for a test for sure today, tonight. You have to do everything again. If you don't much really need look at the notes again, you can just feel free to do it yourself. Eventually you'll be fine. You probably are fine with for tomorrow's test. Okay, if you have to refer back to your notes, it means you probably need to review more. If you don't need the notes and you can directly do it, you're fine. Alright, so you got the same thing? So first, since I've already said x equals 8 sine theta, So you take the derivative dx equals 8 cosine theta d theta. Then you plug everything in. Okay, so how many of you ever got 64 sine theta squared? I want to know. Okay, not everyone. I want to know why you don't get that. And use power reduced formula. Okay, you can look at yours and mine, see if there's any place you did wrong. Check it again. Yeah, so I think there's one part from here, from this one to the bottom, there's one thing you need to do, sine 2 theta change into sine theta cosine theta. Then you can bring the theta back into the x. Okay? Alright, this one is a must know how to do problem for sure. Okay? And I will, let me see. The number 10, I'm going to skip number 10. Okay, number 10, you go back and do it yourself. It's the same idea. Alright, so did you copy down the answers? Are you good? Yes, everyone? If you need more time, just let me know. I can let you copy it down. But you still have the videos at home, you can watch it again. Okay. So number 10, I will skip it because I don't really think it's really hard. So it's going to be I really don't think the number 10 is a very hard problem. So number 11, I'll skip it because number 11 is pretty simple. You just x plus 9 and x plus 2, x plus 9 dx. These two cancel out, so it's just 1 over x plus 2. dx is ln x plus 2. Okay. Also number 12. X power 3 minus 4x x squared plus 60x plus 60 dx. Okay, so I want you to do this one by yourself, because when you do it, you whether you know how to do it or not. If you don't do it, you still don't know if you know or not. Are you done? Did you get the same answer as mine? Negative 15, 7, 23 for the coefficient? Yes or no? You did? Okay. So which means my calculation is right as well. So you got the same numbers, right? Well, if party switch, but you still have these three numbers. If someone got the same answer as mine, which means my calculation here is right. You got the same thing, Zhijian? Okay. Everyone? You got the same thing, everyone? Yes, up to here, I think you don't need any more help, right? Negative 15 ln x minus 7 ln x plus 2 plus 23 ln x minus 2, right? And plus c, okay? You can combine them. You don't have to. That's it. Does it make sense, everyone? Okay. You must know how to do this one for sure. The numbers will probably change, but you have the same questions. Alright. So, next one. L'Hopital's rule. Do you need more time to look at it? If you need, just press the button, please. Okay. So, number 14. No, 13 is just too simple. X goes to 1. Use L'Hopital's rule. X13 minus 1, X22 minus 1. When you use the L'Hopital's rule, it's better you say something about, okay, this is infinity, is 0 over 0 form. So use L'Hopital's rule. Then you take the derivative on both. X goes to 1. Derivative of this is 13 x12. Derivative of this is 22 x21. There's no 0 anymore. Plug in, so answer is 13 over 22. Make sense? Okay. This kind of questions, if I give you this one, it's kind of like the points gave to you. All right. So number 14. I hope you. If I give you L'Hopital's rules questions, I hope everyone can make it right. Those questions are really just a question for you to get points. 4x squared, 7, 5x squared plus 9x minus 2. You know the answer is 5 over 4. Even you don't know L'Hopital's rule, you still know the answer is 5 over 4 because the same degree, same square, that's just coefficient. You can take a L'Hopital's rule, 10x over 8x, 10 over 8, so you still got 5 over 4. Okay, so number 15. You know, limit x goes to infinity, x cubed over e to x squared. Can you tell me what this one is? What do you think it is? 0. Very good. Because you take the L'Hopital's rule, the bottom, the numerator, you eventually going to get 3x squared, 6x, and 6 and 0. But the denominator will never disappear. Is a natural, is an exponential function. You keep taking the derivative, it will never disappear. It's 0. And number 16, limit x goes to infinity, 1 plus 1 over x to power x. Can anyone tell me what this is? E. Very good. Yesterday, I think it's Travis. Someone told me is E. It's very impressive. Yesterday we did the same thing. Okay. So, but you must know why this one is E. You know how to get the one is E, right? You just set up x goes to infinity, and 1 plus 1 over x, x equals y. Then you take ln on both sides. Ln y equals limit x goes to infinity, x ln 1 plus 1 over x. What you need to do, use L'Hopital's rule, limit x goes to infinity, ln 1 plus 1 over x divided by 1 over x. The key point is change that x into the denominator. Okay. Then you have limit x goes to infinity. Take the derivative of both. So it's 1 over 1 plus 1 over x. Multiply the derivative inside 1 over prime or 1 over x prime. 1 over x prime for the bottom. The derivative cancel out, so you plug x infinity into here, just the 1. So you got y equals e to power 1, so equals e. That's why you got the whole thing equals e. Make sense? Yes? Okay. So the key point is changing the x into 1 over x. Then use L'Hopital's rule, take the derivative on both top and the bottom. So then these two cancel out. You got plug x, infinity in is 1, so you got e. Okay. This one you would bet to look at this one as well. Okay. Number 17. I'll skip this one. It's not really hard, right? Improper integral of e to negative 3x, I think you should be able to do that for sure. E to negative 3x, 0 to infinity dx, that's just a simple one. You have to change one thing. B goes to infinity, e to negative 3x over negative 3, plug b and 3 in. And just check it and see what it is. Okay, number 18. 1 over x cube 1 to infinity dx. This one will give you a limit. B goes to infinity. X to. Can anyone tell me? It's just so simple. I want to ask you. Negative 2 over negative 2. Very good. And plug B and 1 into it. Okay. Next one, negative infinity to 0 x e to negative 9x dx. Okay, so I want to try this one right now by yourself. This one. Okay, are we done, everyone? It should be pretty simple, right? U and dv, u is x, 1, 0, e to negative 9x, e to negative 9x over negative 9. e to negative 9x over 81. Positive, negative, positive, cross them. So what you need to do is just need limit a goes to negative infinity and negative e to negative 9x negative 9 minus 81 e to negative 9x. Plug a and 0 in. If you plug 0 into it, this is 1, so it's negative 1 over 9 minus plug 0 is negative 1 over 81. Plug negative infinity into here is 0 over 0, so the answer is just negative 81 10. You got the same thing? Yes?
Should there be an x in the negative e to the negative x over n portion?
Oh yeah, right. There's an x here. So we don't have this, right? Because plug 0 is 0. So the answer is just that. My bad, I didn't pay attention to that. Yeah. So you got this. Plug 0 into here. Plug 0 into here is 0. Plug 0 into here is negative 1 over 81. Plug negative infinity to here. Oh, you have to check this one. But if you plug negative into here, you know that minus negative into here is 0, right? So you have to check one more thing about that. Negative infinity minus is a plus. A e to 9 negative 9a over 9. Well, then you can use L'Hopital's rule. This is a, this is negative infinity, this is 0. So you can use L'Hopital's rule on this one. You can change that to negative 1 over 81 plus limit a goes to negative infinity and a over e to 9a times 9. And use L'Hopital's once, you got this one goes to 0. Use L'Hopital's rule, this is 1, this is 9, e to 9a times another 9, so it's going to go to 0 and goes to infinity. Is your final answer negative 1 over 81? Yes? Did I do anything wrong? Everyone? x1 0 e to negative 9x e to negative 9x over 9 negative 9 e to negative x over 81. So plus minus so it's minus this and plug 0 into here. This is 0. 0 times anything is 0. You don't have to worry about that. 0 plug into here is 1, which is negative 1 over 80, and plug negative infinity to here. Wait, my bad. I think I made a mistake in the end. This one is 0, but we have not checked this one. Is infinity. Negative infinity plug into here is negative is positive infinity. So this one goes to positive infinity. It diverge actually. Plus a goes to negative infinity. 81 e to negative 9a. Since a goes to negative infinity, this negative positive, so this whole thing will diverge, right? Everyone, what did you got? I want to know what you got. Anything wrong? Okay. Okay. All right. So. Alright, so let's continue. Last one is ln x 1 over x. This one is pretty simple. 1 to infinity ln x over x dx. This is one converge or diverge. So how do I do this one? Can anyone tell me? U equals what? Yeah, so du equals 1 over x dx. So the answer is plug x equals 1 into a 0, plug infinity is infinity, and then u plug into here. It's going to be Lx is u, 1 over x is du. So it's going to be limit b goes to infinity and u squared over 2, plug 0 and b into it. So it's a limit b goes to infinity, and since u is ln x squared over 2, plug 0 and b, plug infinity into this one, so it goes to infinity, so it diverge. Okay, and then we're done with the these 20 questions. They have 2 minutes, 1 minute. So is everyone okay with the chapter 8 quiz? If you need to prepare for the test, you need to do all of the chapter 8 quiz, especially the one I just marked. For sure, you have to do those for sure. All of them, basically, I think you have to do all of them again by yourself. Okay, today. And let me see. Wait. We don't have too many time. Do you have any other questions? Sequence, you can do a little bit. Section, basically, you have to focus on section 9.1 and 9.2, geometric series, nth term test, and sequence. Okay, so chapter 7. Let me see. Did I give you any homework? Chapter 8 homework. Okay, homework 8. Homework 7. Did I give you any sequence on homework 7? Okay, so if you want to look at the sequence problem, you can prepare for it. Look at the homework 7 sequence problems. Would that be okay? Since those ones have already finished, right? Last weekend. So if you want to prepare for it, just look at homework 7, the sequence problem. You don't have to worry about the homework 8 problems. Just homework 7, the sequence problems. I mean, basically it's from 20. From problem 20, 17, I mean just the last 15, the last half of homework 7 and chapter 8 quiz. Those are your studying materials for the test. Alright, any other questions? If no question, then good luck. I think you'll be fine, okay? Don't worry too much, we should be fine. Alright.